video demonstrates Swarm Map-based Bayesian Optimisation as a method for allowing robot swarms to adapt rapidly to changes in the surrounding environment or fault conditions. We study this on a foraging task where robots must gather food items from a food source and bring it back to the nest. The approach taken is behavior adaptation with two phases. First, one involves a behaviorally diverse archive of neural networks controllers as a priors, and then at the application one adapts by searching for the best controller. This is Swarm Map-based Bayesian Optimisation. The best controller with the most food items collection is now shown, allowing at most 30 evaluations. In normal conditions, with no fault or environmental perturbation, the robot swarm is efficient, with each robot going back and forth from a food source to the nest. However, after proximity sensor faults, different proximity sensor faults are injected to different robots, the same controller fails, many of them wandering around aimlessly, and some of them getting stuck altogether. SMBO efficiently uses the behavior performance map to guide its search as a Bayesian prior. The recovered behavior after the search is highly performing, with 4 robots going back and forth efficiently and 2 of them being ignored. Without the prior, the recovered behavior is less efficient, many of them walking around randomly. We also study decentralized adaptation, where each robot selects its own controller and then shares performances with others. This allows more robust communication with fewer failure modes, and also allows us to compose heterogeneous swarms, in which each robot with the same fault conditions has the same controller. In this case, we can see that SMBO decentralized efficiently moves back and forth from food source to nest. Removing the sharing, such that each robot has a different controller, makes the recovered behavior less efficient. If the surroundings change rather than robots being affected by different faults, we can safely share across the entire swarm. The food scarcity to X condition is one example where only one food item remains and 2 times the number of agents is included. In the normal case, this fails. With SMBO decentralized, a 7-fold improvement, and with SMBO decentralized with no sharing, only a 2-fold improvement is seen.